Good. Now, here's the question. Am I recording? Okay, let's try this, guys. It's recording. Lesson 2-1. Leads us into this chapter. Linear and quadratic equations and modules. So today we'll just be working with linear. We won't get to anything quadratic. That's more the second page. Looking at various ways to use the linear equation model and quadratic. So first thing, up here. This seems familiar. You remember talking about polynomials? You did it in Algebra 2. You would have in Algebra 1. Okay, so not old news or not new news by any means. But polynomial functions. Any function that is a sum or difference of x values having whole number powers and real number coefficients. So that's what it says. Any function is a sum or difference of x values. So when we talk polynomials, things like x squared plus 2x plus 3, that's a polynomial. It's multiple terms added and subtracted. Something like 2x minus 5, that's a polynomial. You'll notice the specifics. It has to have whole number powers. So that means your power, your exponent, cannot be as a whole number. So 0, 1, 2, 3, 4, no fractions, no negatives. And real number coefficients. So we're not talking about any imaginary numbers. There's a chart here with just kind of some, says names of special polynomials. One that we'll talk about is the zero function. And the zero function knows it's f of x equals 0. Well, what's another name for f of x? Y. So this is the same thing. It has y equals 0. So zero function is y equals 0. Degree-wise, as we talked about degrees today, it's undefined just because it's 0. And the leading coefficient is always your number that is out front of the highest, and so this is 0. The constant function, constant is just where it's f of x equals a, when a is a number, or in other words, y equals a. And so if you think y equals a, that's like your, just y equals a number, so it's a horizontal line. The degree is 0 there, because we can think of it as x is 0, and the leading coefficient is a, because a is what is out front, the number in front. Linear, if it says f of x equals ax plus b, what do you guys think of for ax plus b? That's similar to thinking mx plus b, right? And so degree is 1 because the highest x term has a power of 1. Leading coefficient is a. Why is the leading coefficient a? It's the number out front of that highest power. We've got ax squared plus bx plus c. It's quadratic. Highest power 2, leading coefficient a. We have cubic. Ax cubed plus bx squared plus cx plus d. Degree 3 because it's the highest power, leading coefficient a because that is the coefficient of the highest power term. Okay, this should seem somewhat familiar. Example 1 here. Which of the following are polynomials? So we're going to start by answering yes, it's a polynomial, or no, it's not. For those that are, we're going to state the degree and leading coefficient. For those that are not, we're going to explain why not. So example A. F of x equals 4x cubed minus 5x minus 1/2. And my first question to you is this a polynomial? What? Graph doesn't really tell you anything. You're going to ask the question, is it a polynomial? What does it say about polynomial up top? Sum or difference of x values, so x values being added or subtracted, having whole number powers and real number coefficients. Does this have whole number powers? What are my powers? Power of 3, power of invisible 1, power of invisible 0, since there's no x. So those are all whole numbers, right? Are my coefficients real? 4, negative 1, negative 1/2. Those are real numbers. So is this a polynomial? Yes. So since it is a polynomial, we have to answer two questions. We're going to talk about the degree, and we're going to talk about the lead coefficient. Thoughts on the degree of this problem? 3, because the highest power is 3. In terms of name, we could also call it a cubic. Yeah, we talked about the next last year. Leading coefficient. What's the leading coefficient? 4. Because it's a number in front of the highest degree term. In front of the highest degree, yes. Okay, B. G of x equals 6x to the negative 4th plus 7. Again, I want to know, first off, is this a polynomial? I don't know about the negative 4. Okay, she doesn't know. She's not sure what to think about that negative 4. Anyone want to help her? Let's not be sure what to think either. Okay, so negative 4 is a power. What does it say about powers up top? Has to be a whole number. What are whole numbers? Whole numbers? Remember definition of whole numbers? Whole numbers must be positive. Whole numbers start at 0, and whole numbers are 0, 1, 2, 3, 4, 5, 6, so on and so forth. So this is not a polynomial function. And why is this not a polynomial function? Yeah, it does not have whole number powers. It has a negative power. So I'm going to write here for my explanation. Power is not a whole number. And I've got underneath it, negative. Correct. C. H of x equals square root of 9x to the 4th plus 16x squared. Again, I want to know, is it a polynomial? Why do you say yes? Okay. I agree with all those pieces, other than, what did John mention? The square root. Okay? So here's the deal. I am fully supportive if we are just looking at the 9x to the 4th plus 16x squared. One of the coefficient, or one of the powers, there's another coefficient, it's terms being added or subtracted. What's the catch here? Is it's the square root of all this. We've talked about this lately. Is this square root something I can simplify? We want to, but you can't because it's the square root of two things being added. You can't simplify the square root of things being added or subtracted. So this is not something I can simplify. But one way I could rewrite this if I wanted to is 9x to the 4th plus 16x squared, all raised to what power? The power is the square root here, remember? What's the question? What happened? You guys remember that? Because the 1 is the power on the main part. The 2 comes from the index. Okay, since that is a square root, it's invisible 2 there, so that's a power of 1/2. So what's that help to tell me? This is not a polynomial. Why is it not a polynomial?
Square root.
Basically because of the square root. Again, that power is not a whole number. So power is not a whole number, and then I'm going to put parentheses, square root. And D. K of x equals 15x minus 2x plus 1. Again, as always, my first question is it a polynomial? Yes? Whole number powers, real number coefficients? Okay, so yes, it's a polynomial. The degree is 4. You guys agree with her degree? She says the degree is 4, and that is the highest power, right? Okay, good job, guys. Good teamwork. Okay, so there was no argument about the degree. Degree was the highest power. That was 4, yes. Leading coefficient. I get the 15 is out front, but I tried to make a point earlier that leading coefficient is the number in front of the highest degree. So since my highest degree is 4, what is the number in front there? That does register as a negative 2. So that's the reason this one is thrown in, because you have, leading coefficient is just not the first number. Look for the highest term to go with, highest degree. Questions on that one? We've seen that stuff in Algebra 1, Algebra 2. Okay, maybe it's a slight variation on it, but you've seen it. Let's talk about linear functions. Although said slightly different, this information will be kind of old hat here. So first of all, linear function is a polynomial of degree 1 with a leading coefficient, which that leading coefficient is going to be equal to the slope. If we say f of x equals ax plus b, realize saying ax plus b is the same as saying y equals mx plus b. Okay. Now, side note here, the constant function is the graph of a horizontal line. Okay, so like that y equals a, and then vertical lines also are not functions. And this should say because they do not pass the vertical line test. Okay. Constant functions are one, they're just kind of a little different one. You have to just kind of know that they are not a function. Or that has to do with their power there. Vertical lines are not functions, obviously they don't pass the vertical line test. Notice what it says here, all linear functions. So your typical y equals mx plus b, so that's saying that m and b are present, creates slant lines. So we're talking about those diagonal lines, so they have a positive slope or a negative slope. Example 2 is old news. You know how to do it. The question is, do you understand their lingo here? Write an equation for the linear function f of x such that f of negative 1 equals 2 and f of 3 equals negative 2. I didn't know you. You may take yourself here in a moment. This weekend, I went to bed and asleep by 11 o'clock. Very not normal for me. And I could have taught this on Friday too, but I didn't. Well, no, I couldn't have gotten into it in your class. I didn't touch one of my math section. The ones with the outing calculator. I just don't know the thing. I guessed once 1 year and I got it right. Okay, so let's help this about the year. She should know on the ACT then. Okay, write an equation for the linear function f of x such that those two things are true. First of all, linear function. What's that come here right here? Right, which exactly is essentially y equals mx plus b. Okay, so there's the first thing. And then the big thing that makes this one tricky right now is the form they have it. And I know they like to do this in calculus a lot. F of negative 1 equals 2. What kind of value is negative 1? It's an x. What kind of value is 2? When you plug in an x value into a function, what do you get out? A y value. F of x is y, right? And so they're saying f of x, so f of negative 1 is equal to 2. So that's y equals 2. So what they just gave you there is the ordered pair, negative 1, 2. So what's that say about f of 3 equals negative 2? The ordered pair 3, negative 2. Can we write the equation y equals mx plus b if we're given two ordered pairs? Okay? It's all about the wording. They give you fancy wording here, but that doesn't mean it's not something we can do. So let me write my ordered pairs over here. Negative 1, 2. 3, negative 2. My goal is to get y equals mx plus b. Where do I have to start? Right, what are we finding? Slope, yes? So we're finding slope. So when we find slope here, m equals y2 minus y1 over x2 minus x1 is the typical form I say. Or you'll hear me generalize and say y minus y over x minus x. Or difference in y over difference in x. So what do you guys want to do on top for y minus y? Okay. And it says negative 2 minus 2. If she has us do negative 2 minus 2 on top, what must we do on bottom? Same order, so 3 minus negative 1 is what I'm going to write. What do you know about negative 2 minus 2? Negative 4. 3 minus negative 1. Comes 3 plus 1, which is 4. Negative 4 over 4? Negative 1. So what did we just find? Slope m is negative 1. What do I do with that slope now? Okay, plug in, we find b. I think for the most part you guys still like to use just the general y equals mx plus b, right? You need your slope, and what else do you need to pick? One of the ordered pairs. Which one do you guys want to use? Okay. We'll pick 3, negative 2. Does it matter technically, guys? No. So if we pick 3, negative 2, y is negative 2 equals m, which is negative 1, times x, which is 3, plus b. Negative 1 times 3 is negative 3. So negative 2 equals negative 3 plus b. And 3, negative 2 plus 3 is 1. So now, I know b is 1. Area had m is negative 1. What's my answer? Y equals negative 1x plus 1, which you'll notice I just wrote as y equals negative x plus 1, right? Officially, my direction said to write the equation for the linear function f of x. So if I want to get technical, instead of saying y equals, I should say f of x equals negative x plus 1. Okay. We're running out of time. I'll talk briefly about it, but we'll probably, we'll get to in later examples. Our next topic tomorrow is going to be average rate of change. You'll notice here, before you turn the page, it talks about average rate of change and talks about slope. So slope of a linear function, m equals y2 minus y1 over x2 minus x1, characterizes something called the function's rate of change. So what we call slope, whereas the change in y over the change in x, right, rise over run, that is average rate of change. Now,